actually the first time that we're with a Digitalist event / meetup in Vancouver. I'm a bit excited myself as well. Knowing everybody who's going to talk today, I'm actually not excited because the whole purpose of we go around within Digitalist in all of our cities, Helsinki, Stockholm, San Francisco, London, Vancouver here, to share ideas, lift up the real things forward. We feel that there's too much like noise, just stuff that want to be looking brilliant or made up very polished. You might see today something that is not that polished. You might see also like real life examples. That's especially what we want to do with the world of artificial intelligence and deep learning. We want to show cases from the glass box, like if this would be a car, open the hood, look what is there under the hood. We're also sharing ideas from our life, ideas from how do we work, what are our methodologies, what do we feel works, what do we feel doesn't work. That's the whole idea. That's a lot to do with the Digitalist company culture as well. We want to be very open. And we're succeeding in that very well. If you feel the same way, if you during the night have a feeling that you want to share something on Twitter or Facebook or whatever social platform you choose, there's a couple of hashtags down there. We use the hashtag Digitalist. You could otherwise use some of the other ones over there down. You took hashtag Digitalist on your Twitter, you'll probably see us tweeting on there and can jump into the same ones. Feel free to do so. Some practicalities for the evening. We will have breaks, don't worry. We will have, says the first ones. We will have breaks. The bathrooms are right in your way out. And then the bar is also on there on the right-hand side for those who are looking for that one. There will be food and snacks available throughout the whole evening. If you feel like for a cigarette, you can also do that over there in a designated place outside. And the whole crew, everybody that you see a Digitalist badge or us there in the host, just hail us and we'll help you. It's the purpose to make a good evening. It's the purpose to learn something. We're also going to engage you throughout the evening. We're going to do a little bit panel. I'm going to challenge the ones that are here to talk. I'm also going to challenge you all to take part because we do this together. That has a lot to do. Our agenda drives I'll let Kyle to go on right in a minute. I know he's there already excited of sharing you some of the stuff. I have the pleasure to work with some of the extremely talented people. And we have some of them, 3 of them today here. Kyle from Digitalist here in Vancouver, share a lot about the kind of methodologies and real life examples of what we are doing. Then we have David from Two Hat Security. There. Thank you, David. Welcome. Good. And in the end, scaling deep learning operations, Eero from Valhai. Valhai is a platform product on the deep learning and artificial intelligence that a lot of the machine learning experts in Digitalist use. And they also share the space with us on back there in the San Francisco. Good. 2 breaks scheduled. Yes, then a panel discussion, wrap up of the day. Remember to have fun. The purpose that you came in here is that you learn something, and the purpose is also to have fun because people learn a lot more better when we're very relaxed. I'm sure all of our speakers will appreciate a couple of questions. You can raise your hand when you have one, and they'll take you in between, or I'll host a couple of questions in the end of the meeting. I have a task for you. In the end, on the workshop and panel session in this evening, and you can do this not on the pen and paper, you can do it on your mail. This is so easy. You can do it even in your mobile phone. I will have 2 questions for you. Stay on the bright side, first of all. Both of these questions are related to the positive opportunities that you might come up during the evening. First one is related to the possibilities and upsides in your work during the coming 3 years. If we are here with what you are seeing at the moment, where will we be in about 3 years? Secondly, let's get a bit of a personal in the second question. How will it affect me? If this is what is happening on the world of artificial intelligence, and this is what we can do today, how will my work change? How will my life change? How will the services change that I'm using? I'll remind you a couple of times on those questions, don't worry. But now I give the floor to Kyle. Let's give a big hand to everybody today that comes up here. That's a big thing. Thank you, Kyle.
There we go. Thank you, Teppo.
I'll work this out.
So my slides are on your Mac there.
Go.
I feel like I'm in the way of the projection, but I'll move to the right in a moment.
Hey.
Oh, AI in production. I saw machine learning and execution. That was close, right? AI in production, machine learning and execution. Close enough. Okay. So this is a bit of a different talk than I normally do, in the sense that it's not totally technical. I could talk all day about deep learning, machine learning, convolutional neural networks, and all that good stuff. But today, I'm drawing from my own experiences from rapid prototyping and taking a sprint model approach to AI. And I'll get more into that as we move forward. But first, Teppo touched on a couple of spots about Digitalist. Basically, we are a global company. We're spread across numerous studios with head offices in Helsinki, another one in Stockholm, London, excuse me, and also in North America here, San Francisco, and up here in Vancouver. We're a creative technology company who employ nearly 300 people. So I'm a machine learning engineer and the tech lead for the AI group at Digitalist Vancouver. And so some of the things we specialize in, me, myself, computer vision, semantic segmentation, object detection, facial recognition. But we do have experts in natural language processing, predictive modeling, and just good old-fashioned data science, as that's most useful. Can I get a raise of hands at any data scientists in the room today? Okay. And how about just a software engineer or software developer? Any like management types? Well, cool. Yeah, nice. Like tech leads themselves. Yeah. Ish. Cool. How about in design? How about designers? Great. All right. So this talk is a good mix of all that. And so at Digitalist, what I like as a machine learning engineer is that I have backing from full stack developers as well as designers, to know that our technology is being delivered to the user in a much more meaningful way that I could come up with myself. And so we have a pretty modern machine learning stack. We use for our training, we use Valahai with AWS as our service provider. We typically code in Python. We do all our prototyping in Jupyter notebooks. I'll typically use TensorFlow with maybe the Keras interface. That all rings a bell. And yeah, so basically here's a exhausting list of our technical competencies. Any questions about this? Do any of you use these technologies? Yeah? Awesome. And so I'm just going to go over one of our current projects. It's pretty exciting. I didn't want to get into too much technical details, but I do want to satisfy that for those here. So one of the projects we're currently working on is 2D to 3D video conversion. So it's taking 2D imagery and generating stereo images from it. And what's particularly tough about this problem is that the image quality is of the most importance. Because like in computer vision, I'm used to maybe downscaling the images and like getting a bounding box around the object that you're tracking, and then you're able to just upscale back and it's like it never happened. Or you're doing an image classification task or facial recognition task, and it doesn't matter the resolution of the image. But in this case, we have to maintain 4K resolution. And so there's a lot of challenges that come with that. So just so we're clear, you can see that if we're to input the image on the left, and so if you blink your left and right eye and you see the little shift back and forth, that's basically that. So you see that's the left eye image and the right eye image. So we generate a stereo pair. And so the network architecture to achieve this, has anybody heard of UNet, like you do in Kaggle competitions and stuff? Yeah, really popular. So the encoder decoder network is really resembles UNet. So for those who don't know, essentially you take your input image, you encode it to a more condensed representation, so that, I guess, like the bottleneck part there. And from there, you perform upscaling to generate an image. And in our case, we generate a depth image. So we're able to use depth data to train our algorithm to get depth from an image. And from there, this is the part that's kind of proprietary to this UNet architecture is the rendering network. So we take that depth map and the left eye image, and we're able to do the transformations to generate the right eye image. Any questions about that? I know it's a...
What network is the rendering network? Just kidding.
It's classified. And so here's kind of like a visualization of the steps. So first we're able to generate depth. So you can see that these ninja dudes in the front, so white pixels are close to you, dark pixels are farther away. And so you can see that the bus, it's slanted at an angle. You can see the gradient kind of go across as it goes to the dark, far away pixels. And so from this, we're able to then generate the stereo pair. And so, I mean, like, that's pretty neat on its own, but one of the big kind of feature and value add that this project was about was these people that are in this VR movie industry. They need to use tools to take 2D video and convert it to 3D. It's a very laborious process. You can picture like 60 frames per second, 60 frames for 1 second of video for an entire movie. So one of the things we added is that we're able to interpolate, can everybody see that at the back, between the full parallax and no parallax. So if you were to view this in VR, it's essentially these ninjas coming closer to you and going farther away. And that's to deal with discomfort that people feel when they wear VR goggles with the image being too close. Right. So why we're here. So my experiences from rapid prototyping and taking a sprint model approach to AI. So with the model that I just showed there, and it's a pretty good example because there's a lot of engineering challenges that come with dealing with high resolution imagery, convolutional neural network, really stringent requirements to have to meet. So some of them are data management, so it's moving around those hundreds of gigabytes and terabytes of imagery, as well as distributed training, because we can't be waiting like a week for our model to converge. What we do is we have data parallel training, so we split up our data set into multiple data sets and kind of converge the results together. That's kind of a high-level description of that. So there's also the deploying and scaling of the models and maintaining them, versioning the models. Like, we've had problems where we deploy a model and it's a different version than a model in a different deployment. If only there was a tool that could handle that. I see Arrow smiling back there. And also, you know, poor model performance on production data. I mean, like, you can do all the lab testing that you want. You can get as much training data as you want, but you're never going to be able to simulate the actual real world. And so when you start getting real world results that aren't so hot, you're able to at least take that data, retrain, and redeploy. And it's important that you have that pipeline in place. Let's take a step back, okay? So how are we supposed to be able to solve all these awesome, challenging, rewarding problems if we don't have the projects in the first place? So as a tech lead, it's not just my responsibility to code, it's also my responsibility to bring in new and engaging work for the team to work on so they can further develop their careers and have fun doing it. And so, yeah, if we want to get work in the AI ML space, we kind of have to reach out to more than just the usual customers. So there's 3 types of AI ML customers that I've encountered thus far. And so the first one being, it's pretty common, like tech companies that are looking to just make AI their product. So in that case, like the VR product is you insert 2D, get 3D. That's the value that they're providing. But then there's also other companies, let's say Spotify. They have an existing product, and it's it's a great product. It's a great music streaming product, and they're just looking to enhance that product. And like, so maybe they want to make their recommendations better. Maybe they want to provide a chatbot service to help with customer requests and so forth. But I'm here to talk about this number 3 here, and in my opinion, kind of the most difficult. And so it's non-tech companies. So think like BC Hydro or Fortis or WorkSafe BC, a lot of these large organizations, they're looking to simply increase their profits using AI. They don't care how we do it. They want to use it as a tool to raise their bottom line. And so a lot of them, by this point, they're aware of AI. It's not a new concept to them. And they've probably seen like some of their industry competitors in the news implementing AI and turning profit from it. But they're just kind of unclear on where they start themselves. So our problem as well is that we have all the technical competencies to solve their problems with AI. We found that simply offering our services and maybe showing a good couple of key examples from their industry, it just wasn't convincing enough. Like they're just kind of like, well, it seems like in the big picture, this is kind of a huge undertaking, and like, we'll pass kind of deal, right? And so the solution that we came up with, so I'm going to grab some water. So our designers at Digitalist, they've been taking this design sprint approach for a while. I think it originated with Google. So essentially, at a high level, it's like it's a workshop. So you get everybody in the same room. You want some key stakeholders, like maybe the CEO, managers from different departments, people who can make decisions, as well as give different perspectives from different parts of the company about a problem. And so the Wikipedia definition, design sprint is a time-constrained, 5-phase process that uses design thinking with the aim of reducing risk when bringing a new product, service, or feature to the market. And that makes sense. Like if we the barrier to entry to get these companies to adopt AI, if it seems like a high-risk activity, maybe we can reduce the risk by applying this design sprint approach. So over the last 6 months or so, the designers at Digitalist have kind of showed me the way on how to do this. And I came up with my totally original AI design sprint. It's literally the exact same thing, except they're looking at a neural network, and the guy's wearing a TensorFlow shirt. It's trademark, you see. So it's achieving the same thing, but with AI projects. And so the main goal of this AI design sprint is we're actually looking to provide an end-to-end solution in the form of a proof of concept that solves a small specific business case, but we're actually going to train a machine learning model using their data. And I mean, there's a lot of red tape that goes into actually getting their data in terms of like privacy issues. Maybe their data is handled by a third party, so it isn't so easy at first, but as soon as we can get some samples of their data, it's really where the fun begins. And so the benefits to taking this approach is that, from my experience, it has been appealing to these non-tech companies. They are on board with this. And so, and since we're focusing on solutions that are value focused, that all they want to do is turn a profit. So if we focus on that throughout the workshop, we're really taking care of business. So, and also if we're go end to end, we're able to quickly identify gaps in their data pipeline. And so that's kind of really important, right? So like for machine learning, you need to be able to iterate and retrain and have access to many different features that might improve your predictions of your machine learning model. And if those data pipelines are blocked somehow, it's a pretty big issue. And so you're able to find those right away just in that 5-day process. And so another result is that you're able to scope the project a lot better because you're able to actually get in there and see what their company is all about and see what they're trying to achieve and some of the roadblocks that we might have to overcome in order to achieve this. And you can also manage the customer's expectations because they see how much work just goes into even just creating this simple model, all the moving parts to it. They're not so kind of head in the clouds around all this hype with AI that we see in the news. So this is the 4-day sprint approach. I know I said it was 5 days. That's because there's a part that you don't see. This is Kyle sweating it out, doing exploratory data analysis on 100 Excel spreadsheets of data from 10 years. So that's the secret one. But essentially in this 4-day approach, at a high level, the first day it's unpack and decide. So it's kind of like just laying the groundwork for what's about to come throughout the week. And I'll show some visualizations that I found during the initial exploratory data analysis, and that's usually really constructive. And then essentially we force them to decide on a target that's achievable within this 5-day window that we can actually see if this proof of concept works. And so day 2, what we do, it's not very nice. We force them to fill out a business model canvas. If you've seen it, I'll show a picture of what it looks like. So we say, you think that's great, so explain how you're going to make money from it. Explain who your customers are, explain how you're going to do it, who your key resources are in your channels and so forth. And so that's a really useful exercise. And then by day 3, and I'm also not saying that the nights between day 1 and 2 is also furious coding, right? So between day 2 and day 3, I get feedback as to what they'd like to achieve in terms of proof of concept, and so I'll be coding up that machine learning model kind of overnight. And so by day 3, we have a prototype to show them. And so what we do with the prototype is we present it to actual real users and start getting real user feedback to see if they actually find this stuff useful. And so then we have one more final day to iterate once more on the design, so that by day 4, what we have for this client is we have a proof of concept, yes or no, does it work? And we can also use all the insights that we got from this exercise as to what comes next, so we can plan. And so I have a couple pictures of, this is our research and discovery team. And so all 4 of us will kind of show up on-prem and run this 5-day workshop with you. So on the day 1, this is a really important part, is you want to educate them because they know their industry better than you. I promise you that. You look at their data and you're like, oh yeah, of course, this happens. And they'll always surprise you with some kind of insight that you never could get yourself. So what you'd like to do is educate them on the capabilities as well as the limitations of machine learning, so they can form their own opinions. And then we do a mapping exercise where they're going to map out the pain points within their organization that they feel, now that they know what AI can do, where AI could help them. And then they vote on those to narrow it down. So then day 2, we take that target proof of concept and they fill out this business model canvas. And believe me, having all those people from throughout the company in the same room, it had almost never happened before at their company. I mean, they said that, they're like, we've never even been in the same room together all at the same time. So they're coming up with something that really, really is going to generate value if it works. And so day 3, you come in, the user actually comes in and tests it, says I don't even know where to click, or what is this? But it's very, very useful. So then by day 4, we're able to plan, decide what the next phases of the project are, because we have at least a clearer view of, if we were to implement machine learning AI at our company, what does it actually look like, and what's it going to take to get there? All right, this is interesting. So it's actually a real customer problem that we encountered, and through this workshop. So this is what they came up with through the day 1 exercise. They say that we have issues. So a lot of construction work, it's seasonal. So in the winter, you typically will lay off a bunch of workers, and once it starts heating up again, you ramp up your hiring. And so they have issues with timing the increase and decrease of hiring during peak and off seasons. And so what they were able to provide me with was 3 years worth of tickets logged in Excel spreadsheets. And the features that were in each of those logs was the data was received, when it was complete, the city it was performed in, and the contractor it was assigned to. So that's enough information to at least provide some kind of insights, like where it is. That might be an indicator on on the typical volume of that day, and the data that's received, that's obviously a big one. And so I provided them, I mean, it's a pretty simple kind of visualization, but they had never seen this before. They had never pulled out their 3 years of Excel spreadsheets into one single graph and seen, well, you know, it's definitely a seasonal up and down, let's just say like cyclical graph here. Like every spring you get a spike, and every winter it basically goes down to zero. And so the first thought that I had was, well, let's plot the temperature of the closest city. Okay, kind of tells us maybe there's a correlation between temperature and the actual volume, but you don't want to make that assumption, because maybe they're both just cyclical seasonal variables, right? Like you don't want to automatically make that correlation. But even just showing this was like super valuable. Like I couldn't believe like that they had never seen this before, and just showing them this. One person says, "Oh, 2018, how come it has less?" And somebody else said, "Oh, it's because there was an election that year, and and nobody wants to take on the budget for all the construction jobs, so there's typically less tickets." I'm like, wow, I would never think of that myself, right? So it's extremely useful exercise to put this stuff up. So for the actual ML model, so to simulate this actual proof of concept, we took, it's kind of the same color as my sweater, the blue stuff from the blue data points. So starting from let's just say, I think it's early spring, all the way down to January 2015, you take that and we train a machine learning model with just that data. And so the data on the right is kind of our holdout set. So we don't let the machine learning model see that data. And so if we're able to predict, we can get an accurate kind of evaluation of our model performance by comparing the predictions to the actual data. So let me just show you the scenario here. So it's basically right here. So if we zoom into there, so there's about 3 months worth of data prior to this situation. So we're pretending that we have our machine learning model deployed. It's been gathering data for the last 3 years. And we're sitting here in March of 2018, and we're not quite sure when the spike's going to hit. So just using historical volume data, this is what it said comes next, right? And this is just historical volume data. That's the only feature in the data set. It's just what happened over the last 3 years. And sure enough, you're able to see a spike is coming. I don't even care how many there are. At least you know that you should think about hiring really soon. And so here's the actual. So it looks like we overshot at first, and so we missed the initial spike, but then we got the next one, and we got like an R2 score of like something like 64% for the first 2 weeks or something, which is actually, it was pretty good. And our user validation, he said, yes, that is valuable to me. So like if you guys are able to like bring the accuracy to something like 70%, even like 65%, we would definitely use this. So that was a big plus. Question?
Which model did you use?
Thanks for asking. All right. So it was an ensemble of a whole bunch of scikit-learn ones. So like there's like random forest regressor. I also used the XGBoost, and I think I used ElasticNet. So it was just an ensemble of regressors together. And so like this, like you could probably actually implement one of these crazy Kaggle ensemble solutions to this, because it's not really like real-time requirements. You only really need to generate a prediction like once a day, right? So you can actually get pretty creative with this stuff. So if we plot in the weather, you can kind of see same scenario, whether it's getting warmer, and the tickets are increasing. Any more questions about this?
Is it the same every year? Can you just start thinking about hiring in March every year?
I know. That's what, because when I saw that, I was like, yeah, guys, like this isn't that. Yeah, so that's one of the key takeaways actually that I have from this is like we'll start with number 2 is just like sometimes just less is more. Like simple data visualizations and dashboards are huge, and at these non-tech companies, like they don't have this stuff in place. Believe me, they don't. And so like start with simple models, maybe even rules-based alerts. If month equals April, higher. Yeah. And so another thing though, and this one was really important to me, is that industry knowledge is just super valuable. Like that election remark that somebody made, like I would never think of that myself. So we're getting multiple perspectives so that when we actually go forward with this project, feature engineering is much easier because you have that insight. That's it.
Did you compare your predictions with the predictions they did just manually?
We don't have predictions done manually.
When did they start to hire?
Good question. Good question. So that's one thing. So this was like very recent. This is last month.
Yeah.
So we haven't gotten back to them in terms of like them actually implementing this into and going forward with a project on this. This is just the results from the workshop in hopes that we're going to be working with them very soon. And so that's what I wanted to see. I wanted to see like, so did it work, right?
Do you have an effect on the real life?
On the real life, yeah. And there was different levels of that too. I mean, like they would like an estimate of the entire year, and I just mean like, just look at the year before. It happens the same every year, right? Yeah. So no, I wasn't able to actually. Let's say like last week's, I wasn't able to see. No. But very excited to try.
Good question.
Yeah.
Hey.
Good question. You came up with the variable of the weather, and you mentioned something about the elections. But is there a way for you to figure out what other variables you should be considering, like, I don't know, wages, location, I don't know, something that can give you more information to predict better?
That's a good question. So the question was, is there a way to let's just say throw a whole bunch of different variables at it and see which one is most important to the model? Is that correct?
Mm-hmm. Correct.
Yeah, so there's a couple different ways to do it. It's called feature importance. So actually one of the byproducts of training like an XGBoost model is it will give you feature importance as a byproduct. So one of the things I found is I was trying to train weather. I did weather, snowfall, moisture in the ground. There was a bunch of variables that I added, and I found that that snowfall had zero importance. I'm like, wow, why? It makes sense because there's like, you can't dig in the snow and the ground might be frozen. And then I figured like, oh, okay, probably because low temperatures it also means snowfall. I mean, like they're one and the same. So they're kind of cross-correlated. Does that answer your question?
I was just wondering if there is a way to figure out what variables you should be considering. I mean, you came up with some ideas, but is there a machine learning type of algorithm that can tell you, consider these variables when, I don't know, I'm just coming up with a scientific way of finding those variables.
Absolutely. So basically you would take features, so anything that has a timestamp that you can align with this data and mark it as the same data point. You can try training a model, and there's other things like permutation importance, where you just permute all that variable and see if it changes the prediction. If it doesn't change the prediction at all, then that feature is not important. So there's different ways to find feature importance, but you do have to try. Like you have to have that data. You can't say machine learning model, search the internet and find like the perfect feature for this. That's not possible.
Just to answer your question, I think one thing you mentioned was ElasticNet.
Yeah.
So that performs feature selection as well, and you could also use a lasso, which produces a sparse model, so it will select the most important.
Awesome. Okay, yeah. So someone from the audience here says that if you use ElasticNet and lasso, it will also give you some feature importance as well.
In terms of productionizing this, say they go forward with it. So how would you actually implement it into production? I mean, would you, I guess, send you the same Excel spreadsheet? How would you embed yourself into that process?
Yeah, that's a really good question. So he says, how would you actually implement this in production? I mean, like, this is AI in production talk, right? So what we found, and one of the good things, as I said, you find gaps in their data pipeline. So what they would talk to somebody, that guy would email them the last year's data, and he would take it from that CSV and produce an Excel spreadsheet. But I was thinking, hey, well, people are calling in. How do they communicate those tickets from that service to this company? And they said, oh, well, there's a database. Okay. So like, yeah, there's a database. So what do we do? First and foremost, we would establish the data pipeline, because that's the most important. We need live data coming in, streaming, so we're able to train and, if possible, retrain the model. But I would likely just host it on an AWS instance. Valahai helps us out a lot with that. Same type. Probably wouldn't use deep learning at first. Probably a simple ensemble of a couple of regressors and scikit-learn. But essentially, we'd start small. We'd try and get it to the user as soon as possible. So if the predictions are good or if they suck, we know right away. We can retrain. So it's setting up our data consumption pipeline, our retraining pipeline, and our deployment pipeline that really helps us and gives us the edge so that we can make agile moves when that's in production and kind of swap out. Does that answer your question?
Yeah, I guess follow up. How would you present results again in a sort of production point of view? You know, do you set up an API? Do you send them your own spreadsheet? And then the results.
Right. Oh yeah. So another important thing is that in this project we would likely start with a baseline kind of dashboard. So a user would log in and be able to see this stuff, and be able to see maybe historical data, maybe projected data, maybe be able to help in the retraining of the algorithm, saying that this was a good prediction or not, so they can retrain. Yeah.
So you said having a dashboard to use to see this data.
Mm-hmm.
I mean, the user was asking a question basically when I need to hire. So that's what they need the dashboard for, is saying that I get hire now one, hire round two person, or whatever the number is.
Okay.
And so they don't need this data. They don't need to see this dashboard. They need to see the implementation, right?
Yes and no, because people still
They
aren't. They want to understand why there still is that need, even if they're not a technical company. They still want to know. They want to have the machine learning algorithm or AI. They want it to help them make their own decision. They don't want it to make the decision for them, especially if it's going to reflect their profits for that year, right? Because in the end, they can't blame the AI. It's like, well, why did you trust it, right?
Awesome. Thank you for all the questions. Thank you for
more questions.
There's one more.
We'll get the panel after. Or?
Yeah, we'll get the panel after,
Okay.
and Carl will be here throughout the whole evening. So you'll have a chance to ask specific questions throughout. I'm trying to look at a little bit our schedule and keep us going today. You were good. It was me who was in the beginning a little bit late. But we're still going to have a good break. We're going to have 8 minutes. That means that we're back. Also, the ones we had about 10 to 20 people following us on the line as well. We're streaming the event. That's part of as a Digitalist, we try to, live like we teach. We try to be online and interact with the audience over there as well. So with that respect, we're back at 6:20, which is in about 8 minutes. Feel free to grab a drink, go outside, and then we'll continue with David Wang. Awesome. Thank you. That was good.
Oh, yeah. Felt like a little cramped up here.
Yeah, it's like
walking
you're
around.
I'm
stuck right here. Yeah.
That's true.
It's all good.
That's true. Actually, the camera would allow you, but the beamer doesn't.
Yeah.
But don't worry about it. Over there on the line, they will see the screen directly. So it's only the audience here.
Okay.
Yeah, because they kind of, we do the slide.
Fair enough. Yeah.
I am. It's on.
It turns on.
It's on already.
Good, good, good. While the last people are getting settled into their seats, let's have this close to standing and moving applause to David Wang. We continue with this same level of bringing in very concrete stuff, sharing experiences, telling how we work, what are the experiences going forward, what do we think, what David thinks in what's next in their approach. And thank you for everybody already now for the active participation during the last speech. We'll be able to grab the discussions during this presentation as well. David, the stage is yours. Okay. With a big applause, of course. Welcome.
Thank you, guys. It's a show time. So today, I'm gonna bring you a topic about the multi-party training with privacy. My name is David Wang. Currently, I'm the machine learning engineering at Two-Hat Security. So in this presentation, I will bring the meaning of why we need multi-party training with privacy, and also how people achieve this multi-party training with different methods. So let's get started. So first, look at this picture. What do you think of from this picture? It's an elephant. Many people, they can access to a part of the elephant, but they cannot achieve the whole picture of that. So this actually is a problem in our machine learning. So currently, our machine learning models, if you want a good machine learning model finally, you need a good data set, right? Without the data set, you can do almost nothing with machine learning. And that is why Hinton, he cannot achieve such performance with AlexNet if there is no ImageNet to provide the data. So a very comprehensive data set is necessary for the success of machine learning. But unfortunately, there are many problems when we're collecting and creating new data sets. Mostly people can only, like the people in the pictures, they can only collect the part of the data instead of a very comprehensive data set. That in this case, if multiple parties, they can hold their data together to contribute together, that will make a far more better data set. But another reality is the data, many data, they are very privacy sensitive. You don't want other people to know. You don't want other companies to take advantage of. So the multiple party training with privacy will be a really meaningful topic for machine learning. So here is a very specific case. Here we have two hospitals. Both of them, they hold some data for the diabetes patients. And now they want to train in some classifiers that can help with the diabetes detections. They want to cooperate together. But as we know, the medical data, they are very sensitive. They cannot share it directly without the permit of patients. But if you want the patient permit of all the patients, you will wait maybe 1 year, maybe 2. At that time, do you still want machine learning? So in this case, how we deal with this case, how we collaborate our data together, but still with some privacy. So here, very smart people, they have some solutions for that. For example, the first option, we can have the encrypted private data. So in this case, basically speaking, they can share the data set after they encrypt it. Before I dig into more details, I need to introduce a little bit more math. don't worry about it. It's just some basic one. I will show you some concept about homomorphic encryption. So here is a very good character of this kind of encryption. Let's say we can have the encryption function, which is called E, and we can have the decryption function, which is called D. The homomorphic function, it have a very good character like this. So if we do the encryption for both data, and then we want the mathematical operation, which called plus, to operate them, they will have the same result if we have the mathematical operation plus. We do this operation first, and then we use the encryption function to encrypt it. Both of their results are exactly the same. So in this case, if we encrypted the data with homomorphic encryption, and then send it to a neural network, and we make the operations in the neural network, they are all like some supported operations like plus for the homomorphic encryption. What will happen? The data, the classifier, they don't know what the real data is, but still they can get some updated result for them. And after that, the holders who have the decryption function, they can already decrypt it and have the final results. So how these two hospitals work together? Let's say these two hospitals, they have both their data. They first encrypt it, and then they send it to the classifier, a neural network, for example, for training. The neural network, it needs to have backpropagation. So they have the backpropagation results that is encrypted. These encrypted results will be then sent to these hospitals. The hospital will decrypt it and add some new data and encrypt it to the classifier. With this procedure, the classifier can be correlated trained, but the data from both parties, they are kept secretly. So for this method, the good side for this method is it allows the data to be never clear to the classifier, but we still can have the training goes on. But the bad side is the homomorphic encryption itself. It requires huge of additional computation. And also, there are limited mathematical operations to do so. As I showed you, plus, it is one supported operation, but for some other operations, it's not supported. So sometimes we need some approximation in the neural networks, which will cause some performance decrease. So what if we make the data limitation more stricter? We say, now even you have the encrypted data, we still don't want you to use that. You cannot share it. So what can we do then? In this case, there is another method, which is called selective parameter sharing. So basically, this selective parameter sharing, it will not send the data or encrypted data to each other. Instead, it will send some backpropagation updates when training the neural network to each party. So here is how it works. Let's say still we have two hospitals. They have their own data in their local data set, and they have a local training model by their own. So and simultaneously on the cloud, it is the place where they collaborate together. They have a new neural network. What happened is when they do the local training, they will do the forward and backward. When they have the parameter updates by the backwards, they will send these parameters to the cloud. So the classifier in the cloud, it can update their parameters by this local data. So similarly, for the second hospital, they can do the same thing. So in this case, by sharing the updated parameters on both sides, they achieved the multi-party training. And even a better thing is, they don't need to send all the parameters. They can send a percentage of parameters to protect, even more protect their privacy. And also, when sending these parameters, they can add in some noise, like, for example, Gaussian noise, to their parameter updates that will further protect their privacy. So for this method, we can say the advantage part is no party, they directly share their private data. And also the privacy can be adjusted by selecting different portions of parameters. We can share 50% of our parameters. We can share 60% of our parameters. That all depends by ourselves, what we want to share. However, the bad side is, if we want to use this method, both parties, they need to train their models simultaneously. Otherwise, this will cause some overfitting problems for one party's data. So here is another example for a similar parameter selective training. This is called by Google's federated learning. Basically, it's the same as before, but it is more lightweighted and can be shared among millions of mobile devices. So now, let's make even stricter data limitations. You cannot even update your model parameters to your collaborators. What you can do? You cannot share parameters. You cannot share the data set. So now there is another trick, method called the private aggregations of teachers. Let's see what it can achieve, the collaborated training. So also, there are two hospitals here. So for each hospital, they can use their own data to train a local data set. Local classifier. This classifier, maybe a neural network, is only trained by their local data. So it's the same as another party. So after they have this, what they will do? They will have a student classifier. That is their collaborative result. They will have a student classifier. They will build up a new classifier in the cloud. And they will have another data set that has not been labeled yet. So this not been labeled data set will send a request to both already trained classifiers. They will give their answers to label this data set. And then we use this labeled data set to train the student model. So by this case, we didn't share any parameters of our local model, even our local data, but we trained a new student data set. This sounds amazing, right? So in this case, we protect our privacy by two ways. The first way is the output of our labeled data set. They are only the ensemble outputs of their local classifiers, which we say teachers. And also, if we want even better privacy restrictions, we can add noise to each teacher's results and then assemble them together. So by this method, we can see that it will allow us a more flexible way for multi-party to cooperation together. And no private data is accessed during this training method. And also the student model, it can learn something from our teacher model. But the bad side is we need to prepare another extra data set for the student model. And this requires some extra training. So basically, that's it for my presentation. So if you have any questions, feel free to ask.
So the main goal is to be able to combine the two private data sets to train the same model? Is that the goal?
So the goal is to combine the two data sets to train a better model.
Yeah, okay. Thanks.
How do you implement that homomorphic
Homomorphic encryption.
Yeah, exactly. Is that some sort of out-of-the-box function you can put your data through, or do you have to call that internally?
Okay, so for the homomorphic encryption, you can treat it as data pre-processing. Does that answer your question?
Yeah, I guess. But so then each hospital, I guess, has to maintain that somehow. I don't know. I'm very illiterate on cryptography. So how would that work? I guess practical.
So for this homomorphic encryption, you can see it as an encryption method that each data holder, they have the key to encrypt it and decrypt it. They are the only one who hold the key. And they are the only one who know what the data really is.
Okay, so yes, there's a ready-made application for that, and also also basically it's the other way to say it is that you have a model of the data, or two models of the data, and the third thing what you get out of this is the representation of the data. And basically when you get the representation of the AI model of the data again back, then you can actually then take it back. But there is a definite use for that.
Okay, thanks. Good. One more question. Encrypted data has a string format, as I understand, but maybe this is what I assume, that if you have a lot of integer data, maybe the accuracy of your result model will kind of decrease because you will always operate with strings at the end.
Yes, by using the homomorphic encryption, not only the integer data, actually itself, it will introduce some level of noise inside. So all of this together, they will both contribute to some decrease of our model's performance.
Again, homomorphic.
Sorry?
The homomorphic encryption, like you mentioned, some is it follows that math. Like I guess union would work too.
Some function instead of some. Yeah, yeah.
This one?
Yeah. So like you mentioned, like there are elemental operations that they commute. I think that's the term. So like union would probably work, and maybe bit shifts or something. But you have to build up the proper full from the basic set that do commute. Are you limited by that? Is that how it works?
You mean the operation is supported?
It's like you only have a subset of operations that commute.
Yeah, exactly.
And
so
you have to use those to build up a proper full encryption.
Yeah, that's a brilliant insight. Actually, in the paper, it says, for example, we have some activation function, say relu or sigmoid, this kind of function. So if you use some homomorphic encryption supported operation, we need to use this kind of operation to approximate sigmoid. This is not exactly sigmoid. Right. We just approximate it.
So I guess that will also use numbers not strings, because for NLP, you would need like word embeddings and encrypted data useless in this case, right?
Sorry?
non-NLP problems, right?
And if you can convert the problem or your data to a matrix, you can all use homomorphic encryption to do so.
It can be used.
So only if you can convert it to a matrix for your inputs.
Okay, we keep on coming with awesome questions. Go for it.
I have a practical question. So I'm wondering how you ensure that the two hospitals, for instance, in your case, are recording the data of the patients in the same way.
That is called data pre-processing. In other words, that's called data mining. That's a really dirty work for the data science to do.
There you go. One there on the back.
I was going through the information you were presenting, and I believe privacy comes from identifying someone. And they don't want to share information as long as you know that this information belongs to someone. Probably going from a different perspective is de-identifying the information. Probably the information itself is not private, as long as you are not able to tag it to a person. In other words, de-identify the information, and then you should be able to use it. So remove the name, or remove the SIN number, or remove things that identify the person, and just use the information. That might be easier.
So it may be irrelevant, but I do have seen several cases that, for example, in some chats, in a chat room, we will remove the user's name, their age. Sometimes they mention it in their chat lines, their age, their address in it. After we clean this sensitive data, we will go to processing it. That is a good way to do so.
All right, David, thank you.
Right. Thank you, guys.
Thank you. And I have one more question from my side, actually, for David. I think Two Hat Security is one of those companies that has, like, throughout the history of existence, done good with AI. You know, your whole existence, if you look at what you do, you're securing chat discussions from the youth, you're doing a lot of security stuff for taxi travelers, you're doing hospitality stuff, you're doing both secure deep learning, taking care of privacy, but you're also doing very good for the society itself, and for human beings in the world. So I think I have always raised my hand for the brand and for the company. But can you see it in the actual everyday work? Do you feel that people are more connected to the work itself, or to the model development, or is privacy like? Does it come from the company culture already?
Yeah, I think so. So actually, we are very proud of our work to do. Our aim is to provide a more safer environment for everybody online. And every time we do this, we think, oh, we achieved something. Right?
Good.
Thank you.
Good. And that's related to the of course to today's panel after we go for it. So remember the two questions. There was this. What do you think, taking it from what technology can do today, where does it lead in my work? What could we as a company, what could I as a student, what could me, then the last question, me personally, where do I feel that we as a human beings can take this when the technical capabilities are actually getting, pretty limitless all the time? Pushing the limit a little bit, and getting our last speaker in here also to get his machine on going. Eero, are you ready?
Yes.
Yes, you are.
Are we going to have a break, or are we going straight? I think we'll go straight.
We're going straight.
Okay.
That's why I was lifting you up there. So having the chance, I think, when starting up with the machine learning environments and the first neural networks, pretty soon, 2-3 years ago, you figure out that, hey, Hetkinen, wait a second. You actually need to push things, your limit comes through of how big of a model you can have, and which infrastructures I have available. And there was this bunch of guys that founded a company already 2 to 3 years ago, and came up with the idea of actually helping out, doing the tools for the gold miners. And happy to have Eero here, CEO of Valohai, telling a little bit of how their platform helps all of us working with the machine learning capacities, and also probably some of the things that have worked and some of the things that don't work.
Is the stream working? It looks like it. Okay. Hi. As Steph already introduced,
welcome.
My name is Eero Laaksonen. I'm the CEO at Valohai. Has anybody heard of us before?
Okay.
Or our clients are living. No one else. Our marketing has something to do here. All right. So Valohai, we're a 2-year-old company. We focus on deep learning tooling. But before I start, I'd like to hear a little bit about you guys. Who of you are software developers? How many people are somehow?
Somehow.
Okay, yeah.
It's a long time. I can still do something. Come on.
Okay.
Yeah,
You qualify. Okay, how about data scientists? Who identifies as a data scientist? Okay, yeah, that's good. Who of you have actually written machine learning code? All right. Oh, it's more hands than all the others combined, which is a little bit weird. Yeah, but I'm happy about that. How many of you have written deep learning code, something you guys consider to be deep learning? A lot of hands too, that's really cool. And then the last question. How many are running it in production? How many of you are running this machine learning in production? We have a few hands, that's pretty good. You guys are. All right. I'm going to talk about a few pain points that go into machine learning and deep learning in production today. I'm going to start off with a Google research from 2015. How many of you have seen this research? If you haven't and you lifted your hand to any of the questions, you definitely should check it. By the way, if you have any questions, you want to stop me at any point or ask anything, I have Valohai t-shirts, and anybody who's going to ask a question or anything is going to get one. And I have a limited amount of different sizes, so it's first come, first served. Some of them are really, really big. All right. So Google looked into their internal machine learning systems in production, and what they realized in 2015 was that only about 5%, which is this year, of the time of data scientists goes into actually building the machine learning models that they're working on. These are the scarcest talent on the earth, the most expensive people you can find in the sort of software development, software side of the world and talent pool. And they're mostly doing stuff that's like DevOps, figuring out the serving infrastructure, data verification, basic stuff. And these people are usually not that good at it. They're coming from a university background. They haven't worked in robust software development teams. They haven't been doing this kind of stuff. So it's usually not their core competence. And why should it be? They have a hugely valuable core competence in somewhere else that not so many people can do. So this is the problem that we started tackling in Valohai, and basically our mission is to change this picture to look more like this. So if you're a data scientist, focus on machine learning code, not the boring stuff. So how we started to approach this issue, our company has a background in really robust software development, so we started looking at software development and what happened in software development in the past about 20 years. We went from deploying like 4 times a year and breaking everything. How many of you have deployed code on a CD? A few guys. But nowadays, if we look at like companies in San Francisco and probably here too, these guys are deploying 10 times, 100 times a day without breaking anything. What happened in between? We had things like version control become a norm. I don't think there's anybody who does code without version control anymore, right? Right? Continuous integration. Are you familiar with continuous integration? Yeah, nodding heads. Yeah, we're doing testing. We're doing it repeatedly. Everything is very robust. Mostly our deployment pipelines are completely automated. There's no one that's SSHing to a server and deploying from the master or doing some, right? What's that? Okay, so but mostly we've automated these things. Then we've started already going to things like microservices, splitting the code up into smaller pieces that smaller teams can deploy and really work efficiently in like teams of thousands of people. But there's one problem. Software development is not machine learning. There are some fundamental differences, and what I'm going to try and drive today is one of the key considerations that you should think about, and why is it so much more difficult to figure out this machine learning pipeline in production. How it looks like when you're doing machine learning. You usually have some sort of raw data. This is a very simple example. Then you have some sort of my first data scribbles.py that's gonna do some transformation on the data. Then you have some sort of data set that comes out of that, and you're gonna come up with a train.py that's gonna train a model. And then you come up with a model, right? Does this look familiar? Yeah, you've done something like this. So when we're talking about software development, we're only interested in the code. The code is the only thing that matters. But now that we're doing machine learning, what matters equally importantly is the data that's actually going through our pipeline. And it's a combination of data and code that actually comes up with the model that's the end result. So machine learning is fundamentally different from software development due to data entanglement. So every single version you're deploying into production is not just code, it's not a version of code, it's a version of data that has gone through a pipeline of different scripts and different versions of code. And you should be able to understand that if you're ever going to replicate it, if you're ever going to document it, if there's going to be more than one people working on it. So we're gonna need new kinds of approaches to document this. So I'm just gonna give an example of what I think you should record every time you're doing a training so that you could actually make your pipeline more robust, more repeatable, testable, checkable. First of all, when you're doing a training, you should always be able to tell what was the actual version of training code. I think some people are already coupling this. But then there's training data. So you should be able to know that if you have a model, what was the training data that you were using and what was the training code. Then there's the test data. So how did you basically split up your data for testing and training? Otherwise, you will not be able to replicate that result ever again. If you're working in actual production environment, you're probably going to be training a model on something other than your own laptop at some point, or someone else is going to take that project and work on it later. So there's a lot of other stuff other than just your code that goes into this. Versions of TensorFlow, if you're using GPUs, you're going to know that CUDA and TensorFlow are a bitch to work with. So you should be able to somehow couple your environment. I think a good way to do this is use Docker. It's pretty much becoming the standard if you look at companies that are doing this at larger scale. Then you're going to want to save the actual model that was the output. And again, we remember the model is not the code. It's very different. It's the output of the code that you're then going to be running with, again, another version of code that's going to take the model and actually deploy it. Then parameters. How many of you guys are doing hyperparameter optimization? Okay, the rest also should be. probably gonna help you a lot. So you should always know that what combination of parameters did you use to come up with this particular model. Logs. So when you're doing a training run, there's probably going to be something that you're gonna be going back to do debugging or understanding what happened in between. So you should definitely save that. And then one thing that is sorry. Yeah, one thing that's relatively new and I only see, like, I talk a lot with Uber, Google, Netflix, companies like this, and the thing that's raising its head is definitely cost. So making it completely transparent to understand how much is it costing for us to develop these models. As a data scientist, it can be really hard to understand what kind of cost you're generating, let's say on the cloud, if you're running huge training runs to understand the prediction of, like, okay, we're at this level of accuracy and we probably want to get there, and looks like we're progressing like this, so we're going to probably be doing this and this much training, and actually understand how much of a cost are we going to generate before we get this model ready. So it might actually be it might not be smart to do something just because it might cost that much, but to have a complete transparency and understand how that cost is generated, and by training run to actually understand how much of a cost are you generating every time you're doing something. This is not easy even on cloud, even though, like, on cloud you can see how much you're using resources. But it's really hard to split that by experiment. So you have to have some sort of system to understand what that actual singular experiment took from you, not just have a log of, like, yeah, we used this 600 hours of this GPU last month. It doesn't tell you anything. It doesn't tell you how much your team progressed using this amount of resources. So that's definitely something you're going to be wanting to look into later on. And then I'm going to argue that training runs are going to only get more and more complicated. You're going to be requiring, your data sets are going to be growing up. You're going to be doing some level of data parallelism at some point. And your hardware is going to get more and more complicated. It's not going to be just a singular machine somewhere in the office or your own laptop. It's probably going to be some sort of a cluster that you're training on the cloud. And this means that if someone ever wants to continue on that work or rerun that experiment, it's going to be very important to be able to document what kind of a cluster and how to set up that cluster and what's the networking inside that cluster and how to basically run this code. It's the same thing as you have Ansible scripts for deploying a complicated cluster online. It's just as complicated to deploy a distributed GPU run. So that should somehow be documented if you want to rerun that. Does any of this make sense?
Yeah. If you optimize hyperparameters, so where is your validation data set? Do you use validation data set?
Oh yeah, definitely. Yeah. Validation.
Part of,
it's like, yeah, definitely. Yeah, if you're doing validation, then definitely. How many of you guys have all of this tackled? Cool. How are you doing it? How are you storing all the information?
Yeah. Basically, I'm using cloud, and even cost, we're using text. So basically, for everything, we just using the same tag, and we kind of try to understand the cost. Yeah, nothing. I can add anything. So basically, covered everything.
Oh, okay. But are you tracking, for instance, your, like, how are you tracking your results in contrast to whatever model? Do you have some sort of database that you built yourself, or where do you store the results?
Yeah, we have a database. Kind of we split in 3 groups: test, evaluation, training data set is all known, right? The only thing I can add is that on clouds, hyperparameter job exists, so you can just run it automatically.
Oh yeah, are you using Google or?
Google and Amazon, they're very similar. We're using Amazon.
Okay. Are you using? Well, okay.
I haven't tried hyperparameter jobs, but it's my next step.
Yeah, the documentation of those jobs is usually somewhat lacking. Like to be able to go back and see, like, what kind of parameters did you go through and what were results.
I can add one more question. So
yeah.
I'm more interested in how to do it continuously learning learning and continuously doing what you get here?
Yeah. I think I can show you. So this is one of the things we've tried to tackle with our solution. This is one kind of approach. It might fit to you, it might not fit to you, but it's sort of an idea how to do this very concretely. So I'm gonna show a quick demo of how we go at this. So first of all, here's Valahai. Everything you see here is created on top of an API. We provide you a graphical user interface and a command line client that you can use. And we're going to create an execution. Behind this execution, there is always a Git repository that has your code. So there's going to be a version of code that's going to be tied to it. That Git repository also has a configuration file that defines different steps of your pipeline that you saw before, like feature extraction, training of particle model, and so on. But I'm just going to quickly show you how creating an execution goes with us. It's a little bit small. Let's see if I can zoom in. So basically, you can just select different types of hardware. In this case, we're going to use AWS. Then we're going to train a model. It's going to be running a Python file that is in the Git repository. We define a Docker image that's going to be able to run that code. We define how to run it, so Python train. Then we have a placeholder for parameters. So we one of the things that we enforce is if you're going to be using hyperparameters, take them in as command line parameters. So there's a standard way of using everything, and then we're able to document that. So you basically just give the hyperparameters that you're going to want to run, and they're automatically documented. Then there's inputs, which is the data that goes into this. In this case, it's on S3.
I have a question on that.
Yeah.
So is that form for the parameters is sort of getting extracted from your commit? So say you're doing like a random forest, it's picking up on that and giving you that sort of option on parameters?
Yeah, you can. It's bringing it from the repository. In there's a configuration file that you add that basically documents all of this. So you document it in code. So it's basically impossible to break it. If you're going to be able to run it, it's already documented inside code. And then you're able to override it here in the execution phase, but we always save that information. So what were the parameters? If I change this, let's say I want to run this, because you don't want to save the actual parameters to Git because it's one version of code that you're going to be running through with 1,000 combination of parameters, for instance. So it's sort of not the responsibility of version control to take care of that and combining the result and the parameter set that you're doing. So we create an execution. Now what we basically do is, once my internet starts working, yes, we set up an AWS instance, deploy a Docker image, ingest your code into that Docker image, then we ingest the data there and just start running it as soon as it starts running. But you also get like real-time statistics from the machines. This is one of the cool things that is often neglected. I see a lot of data scientists that are using too small of a GPU or basically too large of a GPU and not using large enough of a batch size, and it's really hard to you don't remember to go and check how much of memory you're actually using, so you end up wasting a lot of resources. All right, it's booting up, and if we go here to the information tab, basically what we save is all of the information. There's the environment, there's the commit. You can actually jump straight into Git and always see that, okay, this particular commit was used. Here's the Docker image, here's the command, here's the actual extrapolated command if you want to run it somewhere else, if you feel like that. Your inputs, your hyperparameters. Currently you can access cost only through the API, but we're bringing it here also and so on. So sort of using containerization and just good documentation and saving everything that's happening will result in a repeatable result and good documentation of what happened. So now let's say your data. Yep.
Yeah, so I just wonder, support? So do you support GCP, Microsoft Azure?
Oh yeah, we support all the major cloud players, so Azure, Google Cloud, and AWS. We can orchestrate, and also on-premise hardware.
Version control only GitHub or something else?
Sorry, all Git. Everything that's Git will work. GitHub works, GitLab works, private Git works.
You gonna show a demo about model inferencing after this, or?
No, I don't think. I think we're pressed on time. If you want, I can show it one-on-one. What we have done is a system where you can deploy the model onto a scalable Kubernetes cluster as an HTTP REST API, which is really cool because you basically gain whole ownership of the model as a microservice. So you're able to, as a data scientist, deploy the model without having to go to a DevOps team and ask, well, can you deploy this? And they're going to be like, yeah, in 2 weeks' time when we have time and so on.
So you have any metrics or benchmarks, like how the image data are getting served? Like how many images will get served for a basic image deep learning application for model inferencing?
Sorry,
can I know like what are the metrics for how good the images are getting served for image deep learning models that got?
So like monitoring of the actual results and so on.
Yes.
Yeah, we do give some basic information about how the model, like some sort of basic logs. That's still lacking in many ways. Like we could do a lot more to help you understand how the model is performing in production. And that's definitely like what you should be doing and giving that out of the box for data scientists to work on. Yeah. But the short answer is we do a little bit. We don't do everything we want to do. We're mostly focused on right now on the training part and making that scalable and so on.
Thank you.
I'm gonna have to give out many T-shirts now or not.
Yeah, you're still keeping track on them.
Trying to. Yeah, you get a second T-shirt.
For me, it seems like you even use for this thing base like TeamCity or Jenkins. Are you using something like that as a base?
No. Usually, what we see is if you're using Jenkins, if you're building something as a part of a product and you have some sort of a machine learning model as a part of it, so what you can define here is your pipeline, different steps. Like there can be feature extraction on data, and then you generate the data set that you want to train on, and then do some sort of training. It can be several models, and then do an unsolvable or whatever. You can generate a pipeline. Then what we usually see companies doing is have their CI pipeline, and when the CI pipeline is triggered, it calls the training run and waits for a new deployed version to come out, and then you automatically deploy that to a testing environment and then run your testing on top of that model. And then if it's look good, then you can trigger the deployment of the model. So yeah, they call this through the API. So one of the things we do is when you do use Valahai and this kind of an approach, you end up generating a repeatable pipeline that you can actually call from an API and integrate to an existing deployment pipeline, which is cool. Like if you're doing just random scribbles on like Jupyter notebooks, it's going to be really hard to make it productionalized. You're going to have to rewrite everything later on. I guess you guys have seen this. Yeah. So this kind of approach that drives you into something that can be productionalized.
All right.
Yeah.
Keep on coming with. Go on.
So I'm a poor student. I don't have access to a cluster. Can I use this on a single laptop?
Well, if you have a cool project, you can probably get some free credits from us for a cool thing. But
sure.
we don't no, you can't currently use this on your, like you can use it on a private cluster, but it will require us to do a little bit of setup and stuff like that. But there's not like a really good easy way to run it on your own computer. It's gonna be on the cloud, but cloud is like super cheap nowadays if you're not doing something huge.
Okay, so if I get some free credits, is your service free or is that also the?
If you're a student, it's free, yeah.
Okay.
If I need to optimize hyperparameters, and if I want to run the model with different parameters as a single run,
yeah,
can I do it as?
Yeah, so we do. One of the cool things is because, like the okay, depending on how complicated your hyperparameter optimization is, we have a feature that you can use. You can create a task and basically define parameter spaces. Like, let's say we want to try different epochs. We want to try like different dropouts, or you can use a function to define a parameter space. And then, because all of them are like individual things that can be deployed to any machine, and we're working on the cloud, it's possible to do this completely in parallel. And we have like companies that are using 100 GPU machines at the same time to crunch through stuff. So because we're a startup, my demo account only has 5 machines. So I don't crunch through all of our runway. But like here we have 5 machines, 3 of them already started the job. So it's kind of parallelized, makes it a lot faster. You can get rid of those 4 nested for loops and like figuring out how to get the results out of that and make it nice. We also do gather, like, because we document everything in a database, like you have the parameters that you've defined, and then once the result starts coming in, you can see everything in a nice UI. And it can be pulled from an API to like use it in your own system, whatever.
Cool. Yeah.
There's gonna be so many t-shirts.
Yes,
Whoever wants a t-shirt, just come and get it from me. I'm gonna stand there with the t-shirt.
What's like the recommended workflow, I guess? I mean, do you think this sort of completely replaces the playing around in Jupyter, trying different setups?
No. I think Jupyter is a powerful tool. It's for data exploration. It's for understanding what's happening. It's like you can see here, there's no visualization tools. You can't graph your data or whatever. Actually, we've done a really cool thing with two-hat security. These guys built an adapter for Jupyter notebooks where you can actually tag pieces of your code that are then deployed on Valahai, and then so basically you're able to work inside Jupyter notebooks, and you're gonna able to run it, let's say, on your own computer. Or did you have a comment?
No.
Okay. So you're able to work on Jupyter notebooks, but whenever you want to run something on a larger cluster, then you're just going to be able to tag pieces and then run that, and it's documented and so on. So that's the kind of approach that we are taking. I think it's pretty cool, because then you don't have to, like, when you're working with notebooks, if you want to run it on a really big machine, you're going to be paying for hours that you don't really use it. If you work with notebooks, you probably just use the actual compute power under the hood like 20%, 5% of the time. But with this kind of approach, you're able to utilize the hardware just when you want it and pay for it when you want it, but be able to run Jupyter notebooks. So you can basically run Jupyter notebooks on your own machine or some small cloud compute machine, and then execute the large runs on top of a line.
Can I announce a thank you to Eero?
Yeah.
That you go with the t-shirts.
If there's no more questions, thank you.
There you go, thank you. Before you guys start debugging, it's still on a deeper level, which I was waiting for it to become. Thank you for taking it, actually, like we promised on the beginning. We started out with Kyle opening us a little bit of like doing really sprint-wise, fast production environment, making sure that things flow into the actual like real life, figuring out what to actually solve. And we've been very successful with running those AI type of sprints, kind of getting the first hands-on, getting everybody engaged. Secondly, thank you, David. Thank you for sharing the details. Still raise my hat for the whole corporate ethos that you have ongoing. And thank you, Eero, for going so deep. So even though I was about to say that it sounds like a little bit marketing, but then I was, nah, maybe, as long as you keep the command line open, I'll allow that. It's time for networking. I definitely want you to have like 10 or 15 minutes all by yourself. There's still a little bit sunlight out there. Go for the balcony. Remember 2 things. We're going to come here just for a short while to engage all of us to think about what's the future for us to like. It's going to be a 10 to 15 minutes short get-together. I'm going to have the today's panelists, today's speakers here in front as well, to evaluate a little bit the things that we have ongoing and that our minds have geared out during this evening. But before that, have a good 10 to 15 minutes. The bar is still open. You have awesome people around, so hey, enjoy.
Thank you.
Yes, no, we can stream it wise. Yes, yeah, we can pause.
Cool. I had to check how much actually Chris.
So I think he's probably going to be.
I saw you.
He was